So the original space food was cubes and tubes, and the cubes that you see here, whoops, hang on, just lost it. Sorry about that. Okay, so for those of you who are older, you may remember the original space food. So a little bit of history here, cubes and tubes. And the tubes literally was like baby food. It was pureed. It certainly provided the nutrition that they needed, but wasn't very palatable whatsoever. So it wasn't long before NASA wanted to expand and improve the food system. The first significant step forward was the addition of the spoon bowl, which you see here. The spoon bowl was the first, the spoon bowl, which you see at the bottom, the three packages at the bottom there. It was the first package that actually allowed the crew members to use a utensil, a spoon, and it was for freeze-dried products. And they injected water through this valve here at the bottom with a handheld water gun, and then they cut the package open at the top. And it's kind of hard to see, but they had finger loops on each side of the top of the package to actually, they slipped their fingers in and it helped hold the package open. So the bad part about this package was there was 28 piece parts to it, and it was hand assembled. And so even though it added the ability to use a utensil, it was significantly costly and not a very good long-term solution for space flight. Next up was the Skylab food system. And the Skylab food system, what you see here is the Skylab food tray. And the Skylab food system was actually the most sophisticated food system that NASA's ever flown, because it included frozen foods for food. All of the other food systems have been shelf stable except for Skylab. So this tray was very elaborate because these front three wells were controlled by these switches and served as the oven to heat the frozen food items. And there were three of these trays mounted on a pedestal because there were three crew members on board during the Skylab program. So next up came shuttle. And I came to work at NASA as a contractor in 1985, which was very early in the shuttle program. Only 16 of the 135 missions had flown at that point in time. And this is what the original packaging system for the shuttle food system looked like. These cups, these white rigid cups that you see, were for the powdered beverages and for the rehydratables. And in the corner here of each one, inside that little hole that you see there was a septum. And the septum is a little plastic valve with a slit in it. And the slit allowed a needle to be injected into that slit, water injected into the package. And then when the needle was withdrawn, that slit would close to prevent fluid from flowing out of the package in microgravity. So in order to drink a beverage, this straw was inserted, it had a rigid tip. It was inserted through that slit in the septum. Then this clamp was opened and the beverage would flow up the straw. And in between sips, they would clamp it closed to prevent the fluid from flowing out of the straw and out of the package in microgravity. So we use thermostabilized products. Actually, at that point, NASA was buying those from the MRE contractors, the same entrees that the military was creating for their soldiers. We flew some thermostabilized commercial cans. This was like Del Monte fruits and puddings that were in flip-top cans. So when the Challenger accident happened, the crew, we were not flying for almost, well, 2.5 years after Challenger. And so during that time, we were tasked with reconfiguring these packages because this rigid package took up way too much room in stowage to go to orbit and then also in the trash coming home. Because it worked fine when the missions were short and the number of crew members was few. But as the missions got shuttle missions got longer and the number of crew members increased, these packages were designed to be stacked inside each other, and they were supposed to stack them in the trash as well. But the crew members never did. They just chunked them in the trash bag. And so they were taking up way too much room, and all the trash had to come home on the shuttle. And so during the downtime after Challenger, we were given the task of coming up with a new package for the beverages and for the freeze-dried items. We had a packaging engineer that worked on that in the food lab. He came up with this beverage package, which is the same one that is in use today in the NASA food system. He designed this septum adapter. This plastic adapter at the top now holds that septum that used to be in the corner of that rigid package. And this package material is actually the same material that Capri Sun was using at the time that this package was designed. Capri Sun has switched a little bit now, but at the time we got the same material that Capri Sun was using. So in the case of the beverages, they're all powdered commercial off-the-shelf beverages. Crew members inject water from a galley on board. They're able to shake the beverage up to dissolve the powder and then drink through the straw. Use the same straw that was used on the previous package. The initial package that our packaging engineer came up with after Challenger was this package that you see here. And it was actually, it had two parts. The bottom was like a cup, a plastic molded cup. Then the food was put in, the top was sealed on, and then a separate machine packaging machine sealed this adapter into the package. And so that's what was used for freeze-dried for many years, even into the International Space Station. The water is injected by the crew member, and the label tells them how much water to inject and about how long they're going to have to wait for the food to rehydrate. Then they're going to use their scissors to cut the package open. Typically, they'll cut an X across the top of this package, and they would eat out of the package using a fork or a spoon, depending upon the product. The problem with this was the package was made with custom packaging equipment. And over the years, the packaging equipment was wearing out and becoming very expensive to maintain. So a few years ago, for the freeze-dried, NASA switched to this one-piece pouch that just has, it's called a gusseted pouch. You just put the food in and seal it on one machine, and then they inject the water like they did on the previous package. And in this case, they'll cut across here with their scissors, and they'll eat out of the package with a fork or a spoon, depending upon what the product is. Thermostabilized foods during the shuttle program. I mentioned the fact that NASA bought entrees from the MRE program. When we went to Long International Space Station, the problem with the MRE entrees were they were way too high in salt and fat for what we wanted, what NASA wanted for their long duration space crew members. The military has good reasons for having that fat and that salt in their products, but it's a negative for crew members that are in microgravity for long duration. So the original plans for the International Space Station were that we were going to have frozen food again. And so when I first came to work at NASA in 1985, we were planning for a frozen food system for the International Space Station. And it was all being done on paper at that point. But in the mid 90s, when the engineers started looking at how much power they were going to get from the solar arrays on the space station, they basically came to the space station program and said, you could either have freezers for food or you could have freezers for science. So we were back to an all shelf stable food system. And so the food scientist, Dr. Charles Borland, who was managing the food system, the space station food system at the time, he went to the program and he said, look, you had all this money in the budget for us to develop this frozen food packaging system and the products to go in it. Leave that money and let us develop our own thermostabilized foods so that we no longer have to depend on those high salt, high fat MREs. And so at that point in the mid 90s, we actually started in the food lab, the food scientists started formulating our own thermostabilized entrees. There's now about 60 different formulations that are made custom for the space station. Some are entrees, some are desserts, some are fruits, some are vegetables. So a broad spectrum of foods, but about 60 different items that NASA makes custom thermostabilized, and they're all in pouches in order to save weight and volume. There's also a certain amount of intermediate moisture food, not a lot, but these are commercial off the shelf, things like dried fruit, dried beef. And we have a lot of items that are called natural form products. And they're called natural form because they fly in their natural form. Nothing is done to them other than repackaging them. And the reason that there's several reasons for repackaging. One is that all these products are dry products. And so if you send them in bulk, they're going to be very difficult to handle in microgravity because everything's going to tend to float. And so by packaging them in single serving portions, it's much easier for the crew members to use them on orbit. Also, when we package, we vacuum package, so that reduces volume to a small extent. But during the vacuum packaging process, the products are back flushed with nitrogen to reduce the amount of oxygen in the package. And that helps extend the shelf life of the products by lessening the amount of oxygen in the package. NASA also has permission through the Code of Federal Regulations to irradiate meat products to a level of shelf stability. NASA has about 4 different irradiated meat products that they fly. They function just like the thermostabilized products. They're ready to eat. They're in the same type of foil pouch. The crew members warm them up, cut them open, and eat out of the pouch. We also included in the food system are a lot of condiments. In the space shuttle program, restaurant style condiments, the little individual packages were used. The only thing that had to be different was the salt and pepper. Salt is dissolved in water. Pepper is dissolved in a food grade oil similar to a cooking oil. They're in dropper bottles. So in order to use them, the crew member is going to shake the bottle up, open it up, squeeze a drop. They have to touch it to the food and then stir it in. We cannot send powdered salt and pepper because it will get in the air. It can get in their eyes, get in their lungs. So it's a safety hazard. Now on space station, we're able to send because they're up there for a much longer time, we're able to send condiments in bulk squeeze bottles now. Each crew member gets their own utensil kit, and that's because there is no real way, there's no sink, there's no dishwasher on space station, so there's no real way for them to sanitize their utensils. They just have wipes that they can use in between. And so we don't want them, NASA doesn't want them to share utensils. And so each one has their own utensil kit. This is actually what the shuttle utensil kit looked like for station. I think they've limited it, but really the spoon and the scissors, most crew members say that's about all they need. Some like having the knife to spread stuff with, but most say that a spoon and scissors are the most important things to have in their utensil kit. This is a picture of the International Space Station. This was taken from one of the last shuttle flights. And so basically, this is when station was complete, the construction was complete. And so this is basic additional solar arrays, or they're going to be, but this, the solar arrays on each end provide the electricity. The main living and working area is here. And this, if you laid this on a football field, it would basically stretch end zone to end zone. This is the container that we use, that NASA uses to send food now to the space station. When the space station first started, when the first modules were put together back in 1998, station was much smaller, and all the dining, when the first crews came on board in 2000, all the dining was being done in the Russian service module, because the Russians had provided an exact duplicate of their service module from their Mir space station. And so that's where all the dining was done. And so we were sending up food in a metal container that was provided by the Russians. But when the space station assembly got bigger, and we went from a crew of 3 to a crew of 6, a second food preparation area was added over in the US segment. And at that point, we created this bag that we called a bulk overwrap bag, a BOB, and NASA got to have an acronym for everything. So our bulk overwrap bags is how the food goes up to the space station for our crew members. There are about 200 different foods and beverages that are part of the standard menu on the International Space Station. And they're packed what NASA calls pantry style, meaning they're packed in categories. So all the meats are packed together, all the vegetables, all the fruits. There's 8 different categories of standard menu food. And the crew members are going to have one of each of those 8 containers open on orbit all the time. And they're going to select their meals real time from those 8 different categories. In addition to the standard menu, each crew member gets a small quantity of what is called preference containers. And so for a 6-month stay on the ISS, a crew member is going to get, they're going to get 9 bulk overwrap bags like this that are going to have their name on them, and they get to choose exactly what goes inside. It can be more of our items from our standard menu. If they have favorites that they want to eat often, then they're going to add extras of those to their preference containers. Or if they're if they're an astronaut from Canada or from Japan or from Europe, and their country wants to provide special shelf-stable items for them, they can ship those to NASA at Johnson Space Center, and NASA will pack those items in preference containers for their crew members. The way it works on station is that the Russians provide the food for the cosmonauts, and NASA provides the food for everybody else who's on board. So that includes the ESA, the Europeans, the Japanese, and the Canadians at this point. And so in addition to the 9 in addition to the 9 preference, they're also going to get 5 bulk overwrap bags of beverages that are with their name on them. And this is for specifically it's for the coffee and tea drinkers, because if you're a coffee tea person, you have to tell us ahead of time, you have to tell NASA ahead of time how you want your coffee and tea. Do you want it black? Do you want it with powdered creamer? Do you want it with artificial sweetener, sugar? Because on orbit, all they can do is add hot water. And so the beverage containers allow them to customize their coffee and tea. And if they're not coffee and tea drinkers, then they can order other powdered beverages that they would prefer to have. This is a picture of actually inside the Russian service module on Mir, but the one that's on space station, what is an exact copy. And this is a picture of the galley. This is Shannon Lucid when during her stay on Mir, rehydrating a food item from the Russian galley. And this is a picture on Mir also of the table that they have in the Russian galley. And so they do have a dining table. On shuttle, there was no dining table. They ate off of a tray that they Velcroed to their thigh if they wanted to have a tabletop. But on station, they do have tables both in the Russian segment and in the US segment. When the second food preparation area was added in the US segment, this is the rehydration station that was added. And there's a needle that's mounted here that goes into the septum. The crew member dials up the amount of water that they want to add to the package, and the temperature and amount of water that they've selected is automatically dispensed into the package. So on station, they get to choose between hot water or ambient water. They do now have a small chiller. It's about the volume of a typical home microwave. So if they want a chilled beverage, they're going to have to rehydrate that beverage and stick it in the chiller so that it can be chilled prior to consumption. They have a small oven for warming food. So it warms food by conduction. There's 4 vertical hot plates with clamps on them to clamp the foods to the hot plate so that they can warm up the items prior to consumption. So canned items, if they have them, this happens to be a Russian can, or pouch thermostabilized pouches, or a beverage if they want to make it hotter. They're going to warm it by conduction. This is a picture of a dining table in the US segment. And in this particular case, this was when a shuttle was docked. And so this was a joint meal between a shuttle crew and the crew on the International Space Station. The cans that you see here with the green labels on them, those are ESA foods, European Space Agency provided foods. Most of the rest of this is Russian food items. And the interesting thing to note is that these are items that they took, like condiments and things that they took in their preference containers, and they keep them strapped near the table so that they can use them at mealtime. This is actually a close-up of our split pea soup, and I include this in the presentation to show that when we make items, when NASA formulates items that are going to be eaten out of the pouch like this, they have to be fairly viscous because the food has to stay attached to the pouch or attached to the utensil. And so things have to be fairly thick. For instance, we do have there is a chicken consomme that's part of the menu, but it has to be drunk through a straw. But crew members learn by trial and error how to eat in microgravity. And they often said that they have to have a towel handy because things can get away from them when they're dining on orbit. This is a close-up of our freeze-dried tomatoes and artichokes, just to show that people often commented that, you know, it looks terrible when it's dry, but when you add the water, it really looks quite acceptable. A lot of people look at it in the package when it's dry and think it's just not very good, but it really is. It really works out very well. The most popular bread item on orbit is the flour tortilla. When I came to work at NASA, we were sending the food lab was sending fresh bread into the on the shuttle flights for them to make sandwiches with. Not too long after I went to work there, we had a payload specialist from Mexico fly, and he wanted to take tortillas. And the crew members, when they saw how easy it was to take a tortilla and roll something up, and it was like make a sandwich that way without having to deal with 2 pieces of bread and the crumbs that would create in microgravity. After that, they never wanted bread again. They only wanted flour tortillas. And so we were sending fresh flour tortillas that we got at, we went out to tortilla manufacturers in Houston and found the one that had the cleanest, from a yeast and mold perspective, had the cleanest production of flour tortillas. And we would put those on the NASA plane that flew the crew members to Florida, and that's what they sent to orbit. And that worked for quite a while. But then when the shuttle flights got longer, the tortillas wouldn't last till the end of the flight. And the crew members would complain and say, you know, the tortillas, some of them molded before we were able to use them. So what are you going to do now that the flights are 14 days long? We would like to have tortillas that would last the entire time. So we knew that the military made extended shelf life bread products, and did that by reducing the water activity and packaging them anaerobically. And so we actually came up in the food lab, food scientists work on a formulation for our own extended shelf life tortilla. And so we were in the tortilla manufacturing business for quite a few years, had the dough divider, the dough press, and packaged those anaerobically. And we would get about a 4-month shelf life out of those, which was more than adequate for shuttle flights. But after 4 months, they would develop a little bit of a bitter aftertaste. And we got ready to, when we got ready to go into International Space Station, we knew we were going to need longer than 4 months shelf life. And so we were about to start an R&D project to figure out what's causing that bitter flavor, how can we get rid of it so that we can get a much longer shelf life for space station. And about that time, a commercial kit came out, and I believe it was Taco Bell in the grocery store, and it had flour tortillas. It was a kit for making tacos, and it had flour tortillas in it, and it had an 8-month shelf life. So we knew that had to be a low water activity tortilla. So sure enough, we got some, tested them, figured out that the water activity was low enough, and we started buying those from the same company that made them for the commercial market. And so we would package those, and we got a 2-year shelf life out of those. And then several years ago, the military started producing their own version of extended shelf life flour tortillas. So we got some of those tortillas, and in the lab and compared them to the ones that we were using, the commercial ones we were using. And so we got everybody in the lab, assembled, did a taste test, and said, which one do you like better? Did a blind taste test. Some people said, I can't tell a difference. Some said they liked what we were using currently better. Others said they liked the military one better. But when we investigated, we found out that the military actually wasn't making those. They were buying them from the same place we were buying them from and packaging them. So now we buy them pre-packaged from the military contractor. So we don't even have to package tortillas anymore, and they get about a 2-year shelf life. This is a picture in the food lab, 2 of our food scientists preparing one of our products to go into the freeze dryer. It's a picture of our freeze dryer in the food lab. This is in our packaging room. So we use a portable clean room for packaging all the items that we package. It's not like a computer facility where we have to operate at a specific clean room level, but by using a portable clean room, it greatly reduces our potential for contaminating products during the packaging process. So after packaging, everything is post-packaging checked. We have microbiological testing that we do afterwards to make sure that we haven't contaminated. We have a sensory area set up where we bring in volunteers to do sensory tasting for us. We can handle 8 test subjects at a time, and haven't been doing taste testing like this during COVID, but it has always been an important part of our product development and shelf life testing to use volunteers that work on site at NASA as our test subjects. This is a picture in the main part of our food facility where we do food training sessions for the crew members. And these are a couple of space station astronauts. They come in and try all the foods. They do it at lunchtime. They only get a small taste because we only get 4 sessions with them, and they have to try about 200 different foods and beverages during those sessions. So that means they're only getting a small taste of everything, but they score these items, and the scoring sheet that they use, they refer back to, so that when they go to choose their items for their preference containers, they can look back and see if there were favorites that they would like to add more of to their preference menu. For space station, these food sessions are the only time that they will get to evaluate or see this food prior to being on orbit. Our retort facility where we manufacture our freeze thermostabilized foods is actually located at Texas A&M in their electron beam food irradiation facility. They had some empty space, and we put out an RFP back in 2006 looking for someone to partner with us. And the request for proposal, we had several people come back, but A&M won the proposal. And so we partnered with them and opened in some empty space in their facility. We opened our retort facility in 2007 and have been manufacturing our thermostabilized foods there ever since. And we use student labor. One of our food scientists has to oversee the operation, but we use student labor, so it ends up being kind of like a paid internship for the students that work for us. Then I wanted to close out with a few comments about the challenges for going forward for NASA for a food system for Mars. So for that initial Mars mission, the shelf life that's required is going to be somewhere between 5 and 7 years. And that's because So a trip to Mars now takes, with current propulsion technology, about 6 months. And you can only launch to Mars about every 18 months because you have to wait for Earth and Mars to get close together. Otherwise, it's going to take even longer than 6 months to get there. And they want to, most of the supplies that the crews need is going to be pre-positioned, either in orbit or on the surface of Mars. And so by the time food is manufactured, it is assembled on a cargo vehicle, launched to Mars. They confirm that it's there. Then they launch the crew. The food that they eat on that return trip, because once they get there, they're going to have to stay there 18 months at least. So the food that they eat on that return trip is going to be probably about 5 years old. And if that cargo vehicle is not a chemical rocket, but is a solar powered rocket that pre-positions the food and other supplies, then the food that they eat on that return trip is going to be about 7 years old. And so the challenge is, from a microbial perspective, we can certainly come up with food that will be safe to eat for that length of time, but maintaining the nutritional content and maintaining the quality and acceptability of that food because of the chemical changes that are going to occur in that food. Preventing menu fatigue has shown that soldiers in the field, when there's not enough variety in their diet, they tend to eat enough to survive, but not enough to thrive. And so NASA certainly wants crew members, even on that return trip home, to be in top performance. And so we need to have enough, NASA will need to have enough variety in that food system to prevent menu fatigue. There'll be no resupply, and any fresh food that's available is going to be limited to what we call pick and eat, meaning what things like lettuce and maybe cherry tomatoes and stuff that they can grow in a small volume and harvest and eat immediately. So the Advanced Food Technology Project at NASA is utilizing a lot of research to try to help to develop this long-term food system. Right now, they have had tests going on in the HERA test, the Human Exploration Research Analog, which is a chamber where time putting volunteers, and they've been testing food varieties in there. And right now they're in the process of building a research analog at the Johnson Space Center that they're going to use in a 1-year test that is supposed to start sometime this fall. And they're going to be looking at many, many medical and science issues in that 1-year test, but food is certainly going to be part of what they're going to be looking at. One of the things that they're looking at to help extend shelf life is what they call the hurdle approach, meaning they're going to use shelf life extension via processing, but also by reducing the temperature, not to refrigerated temperatures, but to reduce the storage temperature somewhat to help slow down the chemical reactions that will occur in the food. And then I'm going to finish just with some pictures of crew members with food in microgravity. Fresh food is very limited. It was limited on shuttle. It's very limited on station. When a cargo ship arrives to the International Space Station, they always try to have some fresh food on board, but it's like Christmas every time fresh food arrives. And then this last photo was sent to me by a crew member. It was his version of a happy face because he was thanking me and our team for some of the special things that we had provided to him. he used the MRE wheat flatbread, some olives, and cheese spread to make his happy face. So at this point, I'm ready to take questions that people might have.
Great presentation. Thank you so much for giving us lots of insight about the food technology for making food for space, and also for sharing those pretty pictures. It was really interesting to see all of these information and all of this work behind the simple food. But it's just a lot of work to prepare and package and ship actually to space. Thank you so much. So I'm going to read some of the questions. The first question is, any allergen issues, constraints?
Any food allergies? So actually, we have encountered very few food allergies because astronauts have to be so healthy to qualify to fly in the first place. But like, we could not, if someone had a serious, say, peanut allergy, they could never go to the space station because we've had nuts all over that facility. And so it would be impossible for someone with a severe food allergy to say nuts to go up there. Heard ahead of time, someone had emailed me and was asking me about the fact that people do the crew members' taste change when they're in space. And so that has been a debate for all the years that I've been working at NASA. So in the shuttle program, some crew members would say, yeah, the food tasted different when I was on orbit. And others would say, oh, that's all in your head. You know, there's no difference in the way it tastes on the ground or in orbit. And actually, the Canadian Space Agency flew an experiment back in the 80s trying to see if there was a difference. And what they did was they had stock solutions of sweet, sour, salty, bitter solutions that they had the crew members taste and rate for intensity on the ground. And then they were going to have them repeat that in microgravity to see if they rated the intensity the same way. The problem with the shuttle flights is they were too short. And so when crew members first go into microgravity, all the fluid shifts to the upper part of their body. And so they automatically become very congested. Their heads swell and they seem to have a puffy face because all the fluid has shifted to the upper part of their body. And so because of that, it interferes with their ability to smell, to get aroma from the food. And so that Canadian experiment was, they could make no determination from it because of the fluid shifts. And so we actually NASA proposed to repeat that experiment on long duration on space station, but that has never been prioritized as an experiment to fly. But I can tell you that in microgravity, because they're eating out of packages, and because on the ground, when you heat food, all the heat rises to your nose and the aroma comes with it. In microgravity, when you heat, it's going to disperse in different directions. And so that taken with the fact that you're eating out of a package and you're in a closed environment with a lot of other competing odors, it's not too surprising that some crew members find that their taste buds are somewhat dull because they're not getting as much aroma from the food as they normally would. And so it's one reason that condiments are so popular in space flight.
The next question is, are there consideration for the microbiome of the crew?
For the,
Are there consideration for the microbiome of the crew?
you mean like microbiome?
Yeah.
Yeah, actually, okay. So what happens when crew members go into orbit and stay for a long time, their immune system actually does not function as well. And so NASA has ongoing research looking at whether they can improve the immune system of their long duration crew members by using diet to affect the microbiome. So that is being studied, but they have not drawn conclusions from that yet.
What are the most and least popular item?
Well, historically, the most popular item during the shuttle program was our freeze-dried shrimp cocktail because it had horseradish in the sauce. It was a powdered tomato-based sauce, had horseradish in the sauce, and so it had a nice little kick to it. And so crew members really, really like that. But now that we have 200 different foods and beverages in the food standard menu, it's extremely hard to determine what is the most popular and what is the least popular, because we have, you know, so many different crew members and so many different foods. But things like tart beverages tend to be very popular rather than real sweet ones. That historically has been the case. And just things that are easy to eat tend to be more popular as well, because crew members often are very busy, and so they're going to eat quickly and in a hurry. And so things that are easy to eat tend to be extremely popular.
Does the crew get any alcoholic beverages?
Nope. So that's always been a very interesting debate. On Mir, we know that the Russians sent alcohol. NASA has always been very opposed to having alcohol on orbit for safety reasons. I know our international partners, Europeans, Russians, even the Japanese would probably feel differently about that, but NASA's always been very opposed to that from a safety perspective. So legitimately, there is no alcohol on board. Does it get smuggled there? Probably, but legitimately, no, there is no alcohol on board.
How does the space affect sensory perception? I think you answered this question. What do we learn from extended stays in a space like Scott Kelly?
So actually, a lot of what they learned from extended stays, like with Scott Kelly, is what things like the immune system degrades and changes in the heart. Actually, they see structural changes in the heart sometimes of long duration crew members. And so they're studying long duration crew members because when they do a mission to Mars, they're going to have to be aware of the kind of problems and the kind of issues that these crew members are going to have. Because if they're seeing that in a 1-year stay on station, then they're certainly going to see that and even more in a 3-year round trip to Mars. And we currently, there is a crew member on board who will be coming home, Mark Van de High, at the end of the month, and he will have the duration record for NASA crew members because he's going to be over 1 year. He'll even exceed what Scott Kelly did.
Mm-hmm. Are the food safety standards the same between food from Russia versus the US on the International Space Station?
I can't say are the same. The testing that that NASA does and that JAXA does and that Russia does for the food, it isn't the exact same testing, but effectively the standards are pretty much the same as far as microbial content and shelf life.
Actually, it's two-part for this question. Any issues with the food from one country consumed by astronauts from another country?
No, I mean, they trade food all the time. That's they enjoy that. I mean, that's a part, definitely a part for them is to trade food. And for instance, when they're going to be up there on a holiday, one of the crew members will typically they'll devote, say they're going to be up there at Christmas time, they'll devote one of their preference containers and plan a joint meal for everybody who's going to be on board. And they'll typically do a lot of the traditional holiday items. So sharing meals and sharing food is an important part of crew morale, especially for holidays. And during the week, they typically are too busy to eat together every night. But so the Russians tend to dine in the Russian segment and everybody else in the US segment. But they report that they have lots of joint meals on the weekends when they're a little bit less busy.
Have there been any key learnings in your food beverage development which have been commercialized for the benefit of product consumed on Earth?
Actually, probably not. It more works in the opposite direction. We're more monitoring, NASA's more monitoring the commercial sector. I can say that a couple of the formulations that we did for thermostabilized, the military took our formulations and copied a couple of them for the MREs. So we did contribute to the military food program.
If a bag of M&Ms costs $1 to buy, how much would it cost NASA to get it into a package to space station? In other words, can you give us some idea about the cost of foods for NASA?
Well, the cost of the food is nothing. The cost is sending it to orbit. The launching of the food is so, yeah, it is practically impossible. At one point in the shuttle program, they made a determination as best they could that it was about $100 a meal. But it's really impossible nowadays to tell because food is coming from so many different countries and launching on different vehicles, and the cost of launching on one vehicle versus another vehicle is different. But the real cost is not the packaging and the food. The real cost is launching it to orbit.
How accurate was the food agriculture in the movie The Martian? Martian? I haven't.
The Martian.
The Martian.
Not really. I mean, right now, the only food growing, they do have a unit on orbit where they can grow very limited amounts of things like lettuce and radishes and, pick and eat type products. And for that first mission to Mars, they will probably have something similar to that. But the large scale, the type of large scale agriculture that they showed in the movie, it takes a lot of infrastructure, and you're certainly not going to have that on an initial mission to Mars.
Is all the food manufactured by NASA or any manufacturing facilities, co-packers, or partner with brands, or how does that work for new items?
So about 50% of our standard menu is custom that we do at either thermostabilized or freeze-dried items that we make custom. The other half is commercial off-the-shelf products that we buy and repackage to send to orbit. So we don't have direct partnerships with specific food companies. We buy ingredients just like other food companies do. And we buy, like I say, we buy a lot of commercial off-the-shelf products. All our powdered beverages are commercial off-the-shelf. Cookies, crackers, candies, those are all commercial off-the-shelf products that we buy and repackage.
Are there any criteria limiting the types or the amounts of ingredients and additives in the formula?
Not at this time, no.
That the last question is actually my question as well. How will NASA determine shelf life of a food with a required shelf life of 5 years?
So by doing accelerated shelf life testing. So the military has done accelerated shelf life testing in the past. And so there are methods for accelerated shelf life testing. It's not foolproof, but that's really the only way that it can be done is through accelerated shelf life testing, usually through heat, by increasing the heat so that you see the chemical changes occur more rapidly, and you can determine what kind of chemical changes are going to occur in that product over time.
We have another question. How long will it take to set up agriculture and sustainable food production on Mars?
I really have no idea. I really can't answer that question. And yeah, I mean, that's very, very hard to determine if that will, hopefully that will happen at some point, but it will take a very, very long time.
Another question, are there consideration for microbially active foods to address shelf life? Cheeses can age for years. Icelanders routinely store dried fish for years. And of course, wine ages very well.
Yeah, I think that all different aspects of shelf life are being looked at by the researchers at NASA. And so, yeah, I think things like dried meats, dried fish, all cheeses, all of those have possibilities, certainly.
Mm-hmm. Well, thank you so much. Is there any question? You answered a lot of questions. We are 11 minutes past the time. Thank you so much for your time. And
thank you for inviting me.
Great. Our pleasure having you. It was really, really fantastic to have you, and that was a really interesting subject to cover. I want to take this opportunity to echo our upcoming events. Please check our website and stay connected. I hope we can all meet in person this summer in Chicago.
Yes, definitely.
Yes. Thank you. Thank you so much. Have a great, great evening, everyone. Bye.
Bye.
Bye. Right. All right. Take care. I'm going to end this meeting.